When a crime or vehicle accident occurs, the police are the ones who investigate and try to find the person responsible. Sometimes, though, there's lack of evidence, or lack of evidence that the police are able to use, which is when they call in the forensic physicists. Forensic physicists usually have more knowledge and equipment that allow them to uncover more information with little physical evidence. As you probably know, when a gun is shot, it often leaves behind gunshot residue on the clothes and hands of the person who shot the gun. This residue consists of burned and unburned powder components, along with residues from the surface of the bullet, surface of the cartridge case, and lubricants used on the firearm. Analyzing the composition of the residue can help police trace a criminal by the manufacturer of the gunpowder. Police techniques often can't pick up the subtle differences between ammunition powders, but with the use of ion beam accelerators, forensic physicists can. Ion beam accelerators make use of two types of fields, electric and magnetic, which we learned about earlier this year. Electric fields around the accelerator switch from positive to negative at a certain frequency, causing the particles to accelerate, and the magnetic field keeps the particles in the middle of the tubing or steers the particles. The particles travel inside a vacuum, which is crucial for the particles to travel unobstructed, as the vacuum will keep the environment air and dust free. In the case of determining the composition of gunpowder, the ion beam accelerator is aimed at the gunpowder sample. When the beam of particles collides with the sample, detectors can pick up the specific X-rays or gamma rays emitted by the sample. Each element within the sample has specific radiation associated with it, so the forensics physicists are able to tell exactly what's in the sample of gunpowder and how much of it there is. This allows the physicists to create a detailed footprint of the chemical composition of the gunpowder, allowing them to figure out which manufacturer supplied the gunpowder, bringing the police one step closer to catching the person responsible for whatever crime was committed. When investigating an accident, police try to determine if any criminal action took place that caused the accident. Once the accident site and vehicles have been thoroughly inspected, an accident reconstruction can be performed. Reconstructing the accident involves using physics to determine the speeds of the vehicles and their relative positions at different times during the accident sequence. Information such as pre- and post-impact direction of travel, length of pre-impact skid marks, post-impact distances moved, coefficients of friction, impact angles, and vehicle masses are all input into equations to reconstruct an accident. They use kinematics and momentum equations, like we learned earlier this year. For example, let's say the police estimated the mass of one car to be 1,500 kilograms and the other to be 1,200 kilograms in a head-on collision. If they knew the 1,500 kilogram car was traveling at 15 meters per second prior to the accident, they could figure out that the 1,200 kilogram car was traveling at 18.75 meters per second prior to the accident. Using equations like this allows them to determine if any criminal action took place, such as speeding or mechanical violations, and the results provided by the forensic physicists can then be used in court. Forensic science is a wonderful field that can help settle court disputes and catch criminals, when used correctly, doing the public a great amount of good. However, just like in most fields, there are corrupt individuals who will forge evidence or conclusions to meet a quota or further their own agenda, and unfortunately, they are not always caught. Furthermore, these scientists are human and can make mistakes. Scientists deal with probabilities, not certainties. These mistakes can lead to wrongful imprisonment, among other negative effects, giving the field an undeserved bad social reputation. Public crime laboratories, where basic investigations and research take place, are funded by the government, and services are often provided at no cost to official investigative agencies or to the defense in criminal cases. However, furthering research in forensic physics takes place primarily in private labs, which are mainly funded through research grants, which can be difficult to obtain. And if the lab is associated with the university, a large chunk of the money will go to the university rather than to the lab. Running a forensic lab is no cheap and easy process. The cost of replenishing consumable materials, such as pipette tips, can be over $20,000 alone. Add to this the cost of paying the salaries of people working in the lab, and the money necessary for the purchase of new instruments, and the maintenance required to run the new instruments, and the bill skyrockets. However, the benefits of forensic science research greatly outweigh the hefty cost. There are many developments already in motion that hold exciting possibilities for the future. Forensic scientists are looking into new methods of fingerprinting that are cheaper and easier to use, greatly speeding up investigation. For example, a new product called Lumis-Cyano allows police to quickly highlight fingerprints using fluorescence, which is much less tedious and less dangerous than using expensive chemicals to pull the sample print. New techniques of analyzing the most minuscule of clothing fibers are emerging, opening up new leads for investigators when they previously would have hit a dead end. For example, a technique called X-ray photoelectron spectroscopy has been developed, allowing investigators to identify a chemical signature on a fiber's surface samples in a matter of minutes. Scientists are discovering ways of separating mixed DNA so that they can use it, whereas in the past they simply had to discard their contaminated samples. They do so using a software from New Zealand called STR-Mix that is making its way over to North America. Investigations are going to be able to go further than ever before, while also being much faster and cheaper. Forensic science is a very exciting field, one that is able to do a lot for the criminal justice system, as well as aiding other investigations. I hope you enjoyed learning about the basics of forensic science and how much it relates to what we've learned so far this year in grade 12 physics. Thank you!